x squared. What we're trying to do is, let's just say we want to get the area from 0 here up to 2, like what we just did. How do we do that? So you'd integrate x squared between 0 and 2 with respect to x, and you would get x cubed over 3. You would sub in 2 and 0, so let's sub in, well, what's 2? 2 subbed in, 8 over 3, take away 0 over 3, which is 8 over 3.
Nice.
Fantastic. Yeah.
Did you know what? Then you found the area of that triangle, no?
I found this area, yeah, that's that area. Okay.
Is it 8 over 3, like just units?
Yeah, units for the moment, yeah, we'll just go with units. Okay, so let's say I want to make this a volume now. I make it a 3-dimensional shape. Now, forget this for the moment, just forget this, we're just going to look at what bit we got. We got from here up to 2. Imagine I spin this around the x-axis once. Spin it. If I spin it, so it's, it looks like a funnel, or something like that. What would the end of it, if we look straight down this end, what would it look like? Circle, yeah, it would definitely look like a circle, yeah? And as we look all the way down, it'd be a bunch of circles, wouldn't it? Yeah. It'd be all circles. Okay? How do we get an area of a circle?
Pi squared.
Pi times the radius squared. Okay. What is the radius of the end of this circle?
4, 2, pi, sorry. 8.
Yeah, it's going to be whatever this height is here, yeah? How do I get that height? From the function, yeah, I sub whatever the x value is into the function.
4.
Okay. But do you see for all along this, the y value would be its height, yeah? So what's another term for the y value?
Radius?
No, like as in when we can write y or we can write f of x, yeah? The function, yeah. Yeah. So that means that this all the way down along is constantly changing as fx, yeah? So what's the area of just this end circle then, if I call this bit fx?
fx squared pi.
Yeah, so pi or squared, so it's fx to be squared times pi, yeah? Now, if I want to add up all these circles, we have a way of doing that, don't we? We add up all the areas, those little rectangular areas. But if I want to add up all these circles, I also have a way of doing that. If I do the same integral, that same sum thing we did for the areas, we just now add up all these circles using this. So if I do pi fx squared dx, I should get the volume of this shape.
What's the integral of fx? F of x is x.
Well, f of x is whatever function we got. We have x squared here. So if I do that, but sometimes this is a constant, isn't it? So I can really just pop that out in front. We get f of x squared dx.
So it's x quartic? What?
Yeah, what's f of x squared? x4, yeah? x4, okay. And if I...
He's replacing it.
sorry, I did that fast. Yeah, my function in this case was that, yeah. Okay, so x4, so we get x5 over 5 pi times. And what's my bounds? Well, still 0 and 2. And if I do this, I will get a sub in 2, sub in 0. I will get the volume as this thing spins around all the way down. So like a 3-dimensional volume of this shape. And that is volumes of evolution. And there's I'll show you what they have in the book for you. Hold on. I hope I got it right. I was from memory. Yeah. So, yeah, as it spins around, it just creates a bunch of circles, and we got to add up those areas of circles. Because remember, if you do a volume of a prism, what is the volume of a cylindrical prism? It's pi over squared h, isn't it? The area just times by the height. So that's the area, but instead of h, we can't do the same height all the way along because the height is changing, which is where we go for integration. The area under that, it'll change. Every little step, it'll change. If we add up all those areas, instead of saying height, we're going to have to add them all up, those infinitesimal changes, which is integration, adding up those infinitesimal changes. S, remember, is sum. So it's this, it's always this. So you can get the volume of something as it spins around the x-axis by just multiplying by pi and squaring. What's the radius? Well, the radius is the function at any particular point. This, or the y value at any particular point. That's when it spins around the x-axis. Okay? Yeah. Let's do a question. Did I pick the same function? I did. That's not very interesting, but okay. Well, that's the same function. All right. Yes. Okay, let's do something slightly different then. I'm going to do two new things today. That one's pretty straightforward. So you just do pi times whatever the function is. So if it's x cubed plus 3, you would square x cubed plus 3. And like some of you didn't do in the quiz, you can't use chain rule here. You would have to actually square that out. Does that make sense? If you did it on a calculator, it's fine, but the question in the quiz that we had, it was the 1 plus e or something over 3 cubed or squared or something like that. And a lot of you try to use chain rule. No, you just have to square that out before you integrate, because there is no, it didn't work with substitution or by parts or anything like that. You have to do square it out. Yeah. So I was just marking it there. So square whatever the function is with respect to x. You have to square it out. Yeah.
You said that you marked that test.
I'm nearly finished. I'll have them for tomorrow. I thought I'd have them for today, but I got caught up with something.
Is the average grade good? No.
Oh, I do a question by question. I don't know. Some people are doing really well so far, and some people are not. Some people are forgetting plus C's, which is going to cost you a mark every question. Okay.